Okay, everybody. Please have your attention. It's time for the last OSGi talk of this whole Flips conference here. It's going to be a talk by Cummins, the other co-author of Enterprise OSGi Action. So we were very fortunate to have two great authors here this day for doing presentations of OSGi. So please welcome Cummins with a talk, Making Everything Better with OSGi, a happy case study in building a really nice runtime.
I'll be available for autographs, cash donations, that kind of thing afterwards. But before then, I'm going to talk about OSGi. I've done a lot of work with the Apache Aries project, but my talk today, it's much more from a user perspective about what we find when we use OSGi. I'll probably give the punchline away. We find great things, but we'll get there. So let's talk about WebSphere. I think we all know WebSphere. It's a fantastic runtime. It's got really, really powerful capabilities. But there's a bit of a but. In production, you could not do better. For development, maybe the capabilities that make it so great for production aren't quite the most attractive for development. And there's a good reason for this, and it has to do with the history of WebSphere. So I've got here a little history chart that I found somewhere on the web. But you can see it starts in 2005. And this is actually wrong, because WebSphere has been around way, way longer than that. So it's been going since 1998. And in software terms, that's pretty much forever, right? I can't even remember what we were doing with software before 1998. What that means is we've got a big, big, big code base. We have a big, big, big customer base. It takes really big workloads. And all of these things are inhibitors to change. Now, I don't want to stand up here and say, it's so tragic, we have so many customers, it makes life terrible, because of course that's a really good thing, but it does make life harder. And the reason is that, code that has been around forever just comes with certain things. So it doesn't matter how smart you are, how clever you are, how diligent you are. When your code has been around for a really long time, some things start to happen. So you start off, and you've got a few little modules, and you add a few more, and then you add a few dependencies, and then at the end you end up with something like that. And you look at it and you go, what? And then, of course, it gets worse, because there's some bits of the code that you don't even look at. Those are the bits where you say, here be dragons, I'm not going to touch the code. The person who maintained that code left the company 10 years ago, and ever since then we've been afraid to touch it. So this creates some problems. And, we've changed a lot how we do coding between now and the 1990s. So how do you manage these dragons? Well, there's two basic tactics. The first is that you can say, the dragon is over there. I'm over here. I'm going to continue developing in my corner. And maybe if I leave the dragon alone, it will go away eventually. And you can sustain that approach for a while, but then at some point you have to say, no, actually, I have to try and fight this dragon. I'm going to slay the dragon. And so the people in IBM who do this are our clever WebSphere architects. So they are our dragon slayers. And the tool that we use to slay the dragons is OSGi. So we've had a few goes at this. In 2006, we rewrote WAS and we started using OSGi. So we went from lots and lots of jars to, we moved to bundles. We got some modularity because OSGi's package, boundaries ensured that we had the modularity. One thing we didn't do at all is we didn't use OSGi services. And this is partly because moving to not OSGi to OSGi was a big enough change that bringing services into the mix as well, it would have been too much to digest. But we also, we had a lot of assumptions about what order things started in and what would be available and what wouldn't be available. And we had these dependencies between our core elements that we couldn't get away from. So what happened in 2006 when we moved to OSGi? Did everything become perfect all at once? Well, no. We still had dragons. They were better, but there was still some issues. So we had to step back and we had to say, instead of starting from what we've got, what would our ideal application server actually look like? So it would be developer friendly, obviously. We're all developers, so that's our prime motivation. And that means simple, dynamic. It's got to be lightweight, right? We're coding on laptops, so it can't be a big resource beast. It's got to be composable and flexible, and this is what enables a lot of the other things. And it's got to be extensible. And so in order to make it developer-friendly, it's got to have a human-usable configuration. One of the things that goes with being dynamic is it's got to have selectable content. If I'm not doing, really high-end Java EE stuff, I don't want all of it hanging around in my application server at runtime because I'm not using it, so it doesn't make sense. One of the things that goes with composability as well is, you've got to have a clear separation between, well, what's the API? If someone's extending it, they want to see a different set of available packages from someone who's just writing an application on top of it. So, you need some isolation and some boundaries in there. So the sort of the ideal scenario that we had was that you could start with this really simple config that a human could read, a human could check into source control. We'd have a provisioning operation that would go from that config to an amazing started up server, and potentially you would just have the runtime. Or, you might have everything. Or, maybe you have something in between. So then we had to step back and we had to say, well, how do we do this? Particularly because we have an extra requirement is that we want it to be dynamic, so we want to start with the runtime, then we want to add everything, and then we go, oh no, what did I do? I didn't want to add everything, and go back to something that's a bit more moderate in size. And we want to do that all without ever restarting the server. Because we're developers, and we lose productivity when we're watching a server restart. And one of the most important things we wanted to do as well, and this is a major source of pain for our customers, is we often end up in a situation where, of course, we consume open source. And so we've got our runtime, and we've got our little system bundle A that we wrote, and we're using a third-party bundle, SLF4J, taking an example. And then an application comes along, and they also use SLF4J, say. So they get wired to our copy of SLF4J. If that's a good copy for them, that's good. If it's incompatible, then we have chaos. And so the number of times we get these situations where a user application will get wired to a WebSphere internal, and either it will never work or we'll do an upgrade and then that user application will break. It's a really bad situation because we didn't want them, we didn't even want them to see our internals, and yet somehow they're seeing our internals. So this is something that we've just got to fix. But of course, we had a problem. So our cleverest architect, Ian Robinson, he came to us and he said, right, I've defined the problem. I want you to create a lightweight profile of WebSphere that starts in 2 seconds. And we say, yeah, I can do that. But then he had an extra condition. Don't break any eggs. So do you know the expression, if you want to make an omelette, you have to break eggs? Blank faces. Okay, this is really funny, if you know. So the idea is that we have to keep all of the value we've got, and we have to not break our customers, but we want to be able to get all of this value. And how do we get an omelette without breaking eggs? So we stepped back again and we looked at the OSGi maturity model. So this is done by a colleague of mine, Graham Charters, and when organizations adopt OSGi, there's several phases that they tend to go through. So the first one is just ad hoc. We're not really sure what we're doing. We're hardly using OSGi at all. The second one is that you adopt modules. So you've got your manifests, you've got your little jars with metadata in them, but the relationship between them maybe isn't very nice or clean. At the third level, you've got proper modularity, so there's sensible boundaries between your jars. Moving on, you've got loose coupling, so that if you change something in one place, it doesn't break everything else in the system. Level 5 is devolution, so at that point, control is becoming a bit less centralized. Level 6 is dynamism. So at that point, you've got, you're getting pretty close to what I had on those earlier slides, where you have a system where when you change one thing, the right thing happens, and you don't have to bring everything down in order to have the system respond to changes. So I have to confess, I got this off Wikipedia, and I was a bit surprised, because this is the OSGi maturity model that I was familiar with, but Wikipedia had the 7th level as well. So if it's on Wikipedia, it must be right. So I've put it in. Yeah. So looking back at WebSphere, when we made our first attempt at OSGi in 2006, I think we were probably somewhere between level 2 and level 3. I think we thought we were at level 3, maybe with the benefit of hindsight. We were actually closer to level 2, because it was a really big code base, and it was kind of tricky to untangle. But of course, where we want to be is at level 6, because we can't aspire to be Peter Crean.
Yeah, but you can only buy it in France.
Which is very nice as well.
Yeah. And so then the realization that we had was that we could actually move along the maturity model, and we could move from these levels without breaking eggs. And so that was kind of cool. Because we realized that what we could do is we could rewrite the kernel. But once we had a new kernel, we could actually keep almost all of the libraries that we had, attach them to the new kernel, put in some shims to do things like services, and then things would mostly work. And this has actually worked really well as a model. So we started very small. We had something that would run servlets, it would do JSP, it would do a few more things. And then, we've gradually gone through, and we've taken the libraries from the full profile, we've converted them to use services, we've dropped them in, and it's worked, pretty well. And we can have a common code base between the full profile and the new profile, because where the differences are is in how they interact with their dependencies. So of course, when we built this new kernel, there was no question it was going to be OSGi. And in order to get this quality of service that we wanted, we had to use lots of OSGi services. And they weren't an afterthought, they were really core to the architecture. Stepping back, though, to the sort of the first bit of the maturity model, just using modules, we took a different approach there as well. So when we did OSGi in 2006, we wrote all of our manifests by hand. This time round, we have only a really peripheral awareness of our manifests. So we used the Eclipse class path to declare our dependencies, and then we use B&D to sort out generating the manifests. In terms of services as well, we use Declarative Services a lot, and I'll come on to that. And we do that with annotation. So again, there, we don't really have to look in the manifest to do anything. And B&D worked really well for our use case as well, because I mentioned that what we did was we took a lot of these libraries from the full profile, and we just made minor adaptations to make them work with a service-based architecture. And we did have to make these modifications, and what B&D makes just totally transparent is patching. So we'd have our new class file, and then B&D would just generate a new bundle that had most of the old class files plus the one new one, and it would just work. So that was really handy and got us up to speed a lot faster. And one sort of interesting consequence of this is that actually I suspect a lot of our developers don't really even think about the fact that they're using OSGi in that sense, because they don't have to think about manifests, they don't really even have to think about B&D files. It all just, they set stuff up in Eclipse and it all just works. Moving on to the sort of the more interesting things, a lot of what we did was we were using the higher level OSGi specifications, and that's where we got a lot of value. So for configuration, we decided we wanted, XML for configuration because it's a bit wordy, but everybody knows it. But we wanted it to be super concise, so it had to have lots of usable defaults. So this is kind of an example of a minimal liberty configuration. So you can see you have to declare an HTTP endpoint, because that was one thing that we didn't want to default. We didn't want to default to an open port. You had to choose to open a port. And here we've got features. So again, we're saying, I've got a really minimal thing. I want to run a JSP, and I don't want to run anything else, and that's not going to come up in the server. In order to achieve this kind of configuration, well, we said, well, with full WebSphere, we'd had a central configuration model, and when you wanted to make a configuration, change, you had to change that model, and it became really big and really unwieldy. And instead, we said every component owns its own config. It travels around with that component. There's no centralized repository of configuration. And the thing that made this really easy was we used configuration, admin, and Metatype. And so those are both OSGi specifications. And with those two, we were pretty much there. With one or two minor modifications that have kept many of our developers in a job for a year or two. But we'll come on to that. So who here has used Metatype? A couple of little hands. What Metatype does is it gives you a way of validating configuration or validating user input. So you can define how the configuration should look in one place, and then that just ripples through. We use the Equinox implementation of Metatype, but we've extended it a lot as well because we wanted a really nice configuration. So we do a lot of sort of extra things that aren't there in the core Metatype. In particular, but of course, Metatype did allow us to extend it in that way, which is one of the beauties. So we've defined some new types, which we declare with an IBM type. So we've got things like duration, location, password. And this gives a lovely configuration. So for example, if I have a component and it says, I need to take a duration in my configuration, Metatype will convert something like 1 hour, 30 minutes to whatever unit I want to consume it in. Again, for locations, you can say, this isn't just a string. I want to add some extra value to this when the configuration's being generated. And again, we can do some pretty fancy things as well. So we've got passwords, but we don't want to trace passwords, and so we don't want to pass them around as strings. We want to pass them around as something a bit more obfuscated. And so that happens right from when the configuration is consumed. One of the other things that, I've mentioned OSGi services, and I'm going to keep mentioning them because they're so fundamental. We wanted to use OSGi configurations, OSGi services. We definitely did not want to be managing them ourselves. Who here has used the services API directly? Peter Crease has his hand up. Who here enjoyed the experience? See, Tim has his hand up, but that's just because he's weird and wrong. And everyone else says, no, I'm not going to do this again. Thank you very much. Could I please use a utility for this? Since everyone has this experience, there's a couple of utilities, available. The two that are in the OSGi specification are Blueprint and Declarative Services. So, we had a couple of arguments internally about which we would use. We settled on Declarative Services for a couple of reasons. One was just a timing thing. Declarative Services is older than Blueprint, and so when we were getting started, Declarative Services was mature, Blueprint was not. But we also found that Declarative Services did some really lovely integrations with the rest of the OSGi specifications. So in particular, it worked really nicely with config admin, and it worked really nicely with Metatype. So I'll leave that. I've got so many slides about services and declarative services, but the sort of the take home is just that it is so fundamental to what we did. It is the absolute mechanism that enables us to go from something that took a really long time to start to something that started really quickly and was dynamic and had all these really good characteristics. And then when you throw in as well how it interacts with the configuration, it really is magic. Have you heard the expression, any technology sufficiently advanced is indistinguishable from magic? Yeah, that's pretty much where we are. So that has some positive and negative implications, which I'll come back to. So stepping back, I think I've solved a couple of the problems that I wanted to solve, So, I've got the dynamism and that kind of thing. But we had an encapsulation problem still. So if you remember, we really wanted to be sure that applications did not see our internals and that we had the freedom to change our internals without completely obliterating applications. In principle, this should be totally fine with OSGi, right? Because we've got this notion of package privacy. So you can keep your internals as private as you like. You declare your externals, they're public. There's a big barrier between them. Anything that's private isn't seen by the outside world. The problem comes with public, though, and it's one of granularity and scale. So when I've got a really small system with just 3 bundles, bundle B can declare something, bundles A and C depend on it, and there's no problem. If I have a slightly larger system, I maybe find that things aren't behaving quite how I wanted it to be. So bundle B really wanted to share with bundles A and C. It maybe didn't want to share with every single other bundle in the system. But the basic OSGi package mechanism has public and private, and there's no shades of gray in there. There's other problems with granularity as well. But going back to the package one, what we really wanted, is we want to be able to have a box. And we wanted to say, this is the system as a whole, this is what's loaded in Java. But I only want bundle B's externals to be visible to these 2. There's another problem with granularity as well, and that's one of management. When you've got this many bundles hanging around in your system, rolling loose, it can be really tricky to keep hold of them. And if you want to get a set of them and carry them around, you have to gather each one up, and it's a bit of a pain. And it's really difficult to determine just from the feature manifests. Well, if I want to get a running system, which of these bundles do I actually need? And I don't want to be doing this myself. I just want an archive that has what I need that I can carry around. And again, we want this idea of a box, and we want to say, well, let's put these bundles in this box, and let's put these bundles in this box, and then let's be able to carry it around. So of course, this isn't new. There's been so many attempts to solve this problem. So there's Eclipse features, there's Equinox composite bundles, there's Apache Aries Enterprise Bundle Archives, or EBAs. There's Liberty features had to solve this problem as well. So in the first version of Liberty, we rolled our own solution for this. But you can see from the fact that there's so many things in that list, and I haven't even listed them all, this is something that was absolutely crying out for standardization. And this is where subsystems come in. So David's just spoken about subsystems, so I won't talk about them too much, other than to say that they are so good, and they really fill a gap in what OSGi provided. And we use them a lot. And they give us this granularity, they give us this ability to package things up, they give us the ability to keep our public-private separate from our publics, so it's really good. I've drawn boxes here to try and represent that that's really what subsystems are giving you. So they're giving you abilities to put things in boxes and then determine how porous the edges of those boxes are. But sometimes, of course, even better boxes is way better than no boxes at all. But better boxes isn't necessarily all you need. And that becomes pretty obvious when you're doing something like a runtime, because we want our runtime to be extensible. So this is the picture I have where, this box is protecting bundle B's public stuff from everything out here. But what if bundle M isn't like the other bundles? What if bundle M is an extension? In that case, we say we've got to be able to have a wormhole so that bundle M can access the public internals of the application server. And you can't really do that with boxes and make it extensible, because if we extend that box to include bundle M, that only works if we knew about bundle M at development time. And at that point, that's not an extension, that's just part of the server. And we really wanted to be able to be extensible. So what we used resolver hooks. So this is another specification, and we used it, and it solved a lot of problems for us. So I think you'd probably only need to use resolver hooks if you're doing big, deep things like writing runtimes, but it is a really useful little hook. And between the subsystems and the resolver hooks, we now have pretty sophisticated package visibility that allows us to do the things that an application server should. So features can declare an API, and that's public. They can declare an SPI, and that's less public but still accessible. And they can also declare things which are only available to the server internals. And we enforce that isolation with subsystems and with resolver hooks. So one other thing that we do with subsystems is provisioning. And so this is similar to what David talked about, but it's much more local. So we want to be able to dynamically install features based on what gets configured. And what happens is that when you add a feature, it installs bundles, obviously. But then those bundles drive configurations. And then because of the magic interaction between config admin, Metatype, and Declarative Services, you get services. And so changing the configuration drives this really interesting change in the behavior of the server. And the really cool thing about this is that you absolutely do not have to restart the server. It's all totally dynamic. So that's all sounding really good, right? Sold. So did we get rid of every single dragon? Well, yes and no. So we got rid of a lot of the dragons that we did have. We got rid of that inflexibility. We got rid of this great big monolithic server. But we did find some new dragons. So this is the OSGi dragon. Some people think it's a mythical creature. Other people think it exists. I hope you appreciate that. We found that using OSGi gave us some challenges that we hadn't had to deal with before. The first one is about versioning. And versioning actually isn't something that comes from using OSGi, but OSGi makes it a lot easier to manage your versions. And when you manage your versions, you look at your versions. And then when you look at your versions, you say, well, what should this version be? And then you end up in a world of pain. The obvious answer to this is to use semantic versioning. I'd encourage everyone to use semantic versioning. It's a really elegant scheme. It solves a lot of problems, but it's not sufficient for all problems. In particular, semantic versioning just isn't designed to deal with forking. So if you have multiple development streams, it's really hard to come up with a semantic version that can express what's in one stream and what's in the other stream. It makes me sad, and every time we go over this, we start with, but of course we can just use semantic versioning, and then we realize that actually we can't. The good thing about it, though, is that our developers actually never have to touch the versions. This is what release teams are for. So we just carry along, and then at the end, we've got tools that go through and validate that all our versions are sane and roughly meet semantic versioning criteria, and they set the versions. One of the other problems that developers have when they come in and start working on it is they say, yes, I need something. I want to interact with this component, or I'd like to tell this component about myself. And sometimes they go through a couple of contortions before we eventually manage to persuade them. The best thing to do is just to let Declarative Services do it. Do not touch the service API, step away from the service API, do not register services, don't manage your references, don't do anything to do with services, because almost certainly you're going to get it wrong, and Declarative Services would have got it right. That's a lesson that maybe sometimes we have to take a few attempts to learn. One of the other problems that both new developers and experienced developers have is, why is my test failing intermittently? We're so happy when we run a build and we get a test failure, which is a hard failure, because we know it's going to be so easy to debug. And also we back it out of the stream straight away, so it never affects anybody. But the intermittent failures are a lot trickier. So the easy answer to why is my test failing intermittently is because 99 times out of 100, something hasn't happened yet. But unfortunately, there's a bit of a gap between something hasn't happened yet to knowing what that thing was, figuring out why it hadn't happened, and figuring out what you need to do to fix it. And this comes down to, we have to change how we think about development, because we you know, we assume that this is going to happen and this is going to happen and this is going to happen, but when we're using services, things are a lot more quicksandy. And you know, particularly as well, when we talk about dependency injection and inversion of control, it starts to be a bit of a shift in how you have to think. So declarative services, you know, it helps a lot. It means you don't have to worry about, well, are all my dependencies available? But it doesn't solve all problems. You know, we still, the services is one of our biggest challenges in terms of wrapping our head around how to debug things. And it, you know, it's sort of funny, isn't it? Because one of the ways that we achieve the dynamism we do and we achieve the performance that we do is that we are lazy about everything. But being lazy is incredibly hard work. It's actually so much easier to just say, I want this and it's going to be available and then I'm going to do that. But to write your code in a kind of an asynchronous responsive way, and you know, to not do things until you absolutely need to and until all your dependencies available, not so easy. And it's really easy to make assumptions, you know, that because this thing has always been available in the past, it will be available in the future, even though you didn't actually code in any constraints. One of the other questions we ask a lot is the server started? You know, so we've got this box, and this is the server, and we want to know, is it started? But of course, in the service world, we have a lot of services. Some start up at the beginning, some wait for their dependencies, some wait for complex dependencies. And so what we need to say is, you know, in this kind of environment, what does that boundary even mean? What's the server? Because we don't actually know what the contents of the server are going to be. It's flexible. And of course, it's changeable as well. So it might be that we're configured to have those services, but then a user changes the configuration. One of those services goes away. Well, the server's, do we say the server's not started? Of course not. The server is still started. It's just a different server. So we have to think about, instead of asking, is the server started, we have to say, well, what service do I really care about? Is that service started? And so we don't think about the server as a monolithic thing. We have to care about the services that you care about. And it's really obvious when you say it, but when you're writing a test or when you're writing a new extension, it can actually be a little bit of a mindset change. And finally, we have similar things when we talk about our configuration. We've got this devolved configuration where every component contributes its own allowable configuration, and that's great, but it means that if you get something wrong, we say, oh, it must be configuration from some feature that's not installed, which is fine if it is configuration for a feature that's not installed. It's not so good if actually you just got it wrong. So for users, they really want something where they can say, no, I've got this product, tell me what the configuration is, tell me what the allowable configuration is. And especially for tools, they've got to be able to do some kind of validation when you type in the configuration to say, no, probably you got this wrong from the server I know about. So we do have to generate a schema for the configuration, and we do that at build time, and we use it in the tools. So this is a bit of a negative tone that I've just hit now, because you know I've been stood here for 10 minutes telling you about all the problems with services and all the problems, you know, with doing it the way we did it. And you may think, oh well, actually, I am unsold on OSGi. I'm going to renounce my membership of the OSGi Foundation, and I'm going to go away and do everything in a much more static way. Well, don't do that, because it was so worth it. We're so proud of what we've done, and you know the characteristics of our server are so fabulous. You know, like I said, it starts in 3 seconds, but you never actually have to start it anyway because it's so dynamic. You know, the configuration is really elegant, so it's good. But there's one more thing I want to mention. You know, we had this in mind that we were going to do this for development to make it a really enjoyable environment for development. And there's a bit of a parallel with the development of OSGi. Because OSGi was designed for embedded systems, you know. It was designed for these really lightweight, tiny little things that were running with constrained resources. But it turned out to be perfect for our favorite IDE. And you know, that's a massive, really complex system, but the characteristics that made it ideal for this tiny environment also made it ideal for this huge environment. It's a bit the same with Liberty. When we started, we had in mind we're going to make the best development runtime environment we can. So, you know, we were thinking at developer scale. But that actually turned out to be ideal for huge scale as well. So this is a Bluemix server farm. And you can see it's got lots of, well, I say you can see. You'd have to have very good eyes to see the little Liberty instances running in there. But, you know, when we did Bluemix, Bluemix looked at Liberty and said, that is an absolutely perfect runtime for this environment because it's elastic, it's scalable, it's lean with its resources. And so we had this unexpected benefit from the development. So I'll wrap up there. But please do tweet me if you have any questions. And Tim had a code for the book, which I do not, but it was, I think it was a 44% off all books on Manning's site. So do chase Tim down and get that off him. Are there any questions? Stunned silence. Oh, question, right.
Maybe I remember wrong, but I remember last year IBM was all going for a blueprint. Am I misremembering or did it change?
Yeah, no, I think that's, yeah, you're definitely right. And I was one of the ones who was saying Blueprint, yes. They're good for different things. So Blueprint does a lot more for you. So Blueprint, for example, will do proxying so that if the service you depend on goes away, you don't have to deal with that. Your call just gets delayed a little bit while the service comes back. Declarative Services is a lot more low level. So Declarative Services, you have to manage more, but then you also get the things like the integration with config admin. So what I think we'd still say for, and you're right actually, in terms of what the Liberty exposes as well, if you want to use Blueprint, Liberty provides an implementation of that for you and you can use it. If you want to use Declarative Services, it's not quite so exposed from Liberty. So you're right.
I'll put my IBM hat up. I'm Dan Bender. I'm president of OSGi, but I also work for IBM. And generally speaking, where I've talked to customers is they're using Blueprint if they have strong Spring background.